So in this one we're told that in a certain right angle triangle, the adjacent side to the angle theta is 7.5 meters long and the hypotenuse is going to be 9.2 meters long, and we're asked to find the value of theta to the nearest degree. And so what I'd always recommend you do is simply draw a diagram. So we can draw a diagram here now of just the triangle we're dealing with in the question. So we know it's a right angle triangle, and we can fill in our hypotenuse here as well. The hypotenuse luckily we're given in the question, so we don't need to find that, and that's going to be 9.2 meters, so we can write that in straight away. And our second thing here is going to be to label the angle theta, so you can choose either of your acute angles here, so not the right angle obviously, but either of the other two is fine, so we can actually put theta up here at the top. And then the last piece of information we're given is that the side adjacent to theta, which is going to be here on the left, is going to be 7.5 meters. And so this is basically our triangle, and we're going to be using our trig ratios to figure out the value of the angle theta. And I always think questions like this are good practice, obviously for trigonometry, but also good practice for developing your algebra skills, because you're dealing with basically setting up an equation using words, just pure words in the question. So it's good practice for that as well. But the rule we're going to be using to figure out the value of theta is going to be SOHCAHTOA. So this is basically a shorthand way of writing our trig ratios down. And so basically sine is going to be the opposite over the hypotenuse, cos is going to be adjacent over the hypotenuse, so we have OH, then cos is AH, and then tan is going to be the opposite over the adjacent, which is OA. And so basically what we do now is we figure out, although we are told pretty much straightforwardly in the question, which of our two side lengths we have. And so you can see that we've got our hypotenuse, which we're going to call H, and we've got our adjacent, the adjacent side to the angle. So adjacent is a fancy way of saying beside. And so our adjacent is going to be, we're going to call A, and that's going to be 7.5 meters. And so now we can simply set up our equation, and our unknown is going to be the angle here. So we can just simply have cos theta. Theta is a common Greek letter they use to represent angles. So it's nothing too fancy. It's just basically an unknown. So cos theta is going to be 7.5, our adjacent, over 9.2. And just a reminder, this is coming straight from SOHCAHTOA. So this is coming straight from our rule for our trig identities, just to remember them. So cos is equal to the adjacent over the hypotenuse, so that's going to be, if we just write our letters here, that's going to be A over H, so hopefully that's making sense. So when we simplify what's on the right hand side, we're going to get 0.8152. That is basically 7.5 divided by 9.2. You don't have to simplify that straight away if you don't want to. You can leave it as a fraction. That's perfectly fine. I just think it's easier to simplify it before our next step, because the next step is going to take a little bit more thinking than it would otherwise with some of these. But basically now we need to get theta on its own. And so the way we do this is we just take the cos inverse of both sides. So the cos inverse of cos basically means that the cos gets cancelled out on the left, and then on the right we simply have the cos inverse of this quantity 0.8152. That's basically going to be what we have on the right. And this is a process you're going to have to get comfortable with these questions, is basically to move the cos over from being a cos of an angle on the left over to being a cos inverse of a number on the right to find unknown angles. So it is going to take a bit of practice, but hopefully it makes sense here. So we're just taking the cos inverse of our number on the right here to find our angle. And so we can plug this in the calculator. And this is basically going to be equal to 35.39. But then we have to obviously round this to the nearest degree. So we get down to 35 degrees. So that's going to be our final answer for this one.